right, so today we're going to be looking at making equivalent fractions. So let's review, before we start, a numerator and denominator and a fraction named for one. Okay, so let's review. Remember the numerator? When you're writing your fraction, your numerator tells you how many parts are being counted, and your denominator tells you how many equal parts there are in the whole, and it also tells you the size of the parts, okay? And a fraction named for one, remember the numerator and denominator are the same, and that fraction is 1. So what if the numerator and denominator are the same, it equals 1. Okay, so you can have 5 fifths, 10 tenths, 100 100ths. It all equals 1. Okay, so today when we make equivalent fractions, we're going to be multiplying our fraction by a fraction named for 1. Okay, to make an equivalent fraction. So let's look at our on page 227, and let's read the problem together, and then we're going to see how we're going to make an equivalent fraction. Okay? Joe took a pan of brownies and he cut them into third-sized pieces. He kept 1/3 and gave the rest away. He's not going to eat all his part all at once. How can he cut his part into smaller, equal-sized pieces? So the first thing we're going to do is you can see in your book, you have a model of a rectangle representing his pan of brownies. Okay, very good. And he cut it into what size pieces? Third size pieces. Okay, so we're going to divide ours into third size pieces. And what part of this entire pan of brownies did he keep for himself? 1/3. So he kept 1 out of the 3 pieces that he cut in his pan of brownies. He kept 1 part. Okay, very good. Now, we're going to, if you look at your model, Joe cut his part of brownies into, now he has this part, now he wants to make 2 smaller pieces. Okay, so he's going to divide it in half. Okay, so now we're still talking about the same part. We're just dividing that 1 part into 2 pieces. Okay, so we're still talking about, okay, so originally we had 1/3 of the pan of brownies. And let's say that Joe cut the original pan into equal pieces of this size. So we could draw our line all the way across. Okay, so he took the original pan of brownies. Let's suppose that he did that. And not only did he cut his part into 2 pieces, he went ahead and cut all the way through. Now how many pieces of brownie does he have right now? How many are there? There are 6. Okay, remember 6 tells you how many parts there are out of the whole pan of brownies. He has 6. Okay, how many parts are shaded? How many parts did he cut? 2. So 2 6. So 2 6 is our new fraction, and that tells you the fraction of the pan that represents those 2 pieces. So go ahead and shade that in. Okay, oh, it's already shaded, you're just cutting those parts. Okay, very good. So you can rename 1/3 as 2 6. Okay, so now look at B. Suppose that Joe cut his part of the brownies now into 4 equal pieces. Okay, so his part here, we're going to cut it into 4 pieces. So now he has 4 equal-sized pieces out of the whole pan of brownies. Now, suppose he decided, not only in my part of the brownies, I'm going to cut all the pieces the same size in my whole pan of brownies. Now, how many pieces did he cut his pan of brownies into? 12. Now he has 12 pieces. And how many parts are shaded in? 4. So this part, the numerator, is how many parts we're counting, and we're counting 4. Okay, so we have 1/3, which is equal to 2/6, which is equal to 4/12. Okay, so do you notice that this numerator is double this numerator, and this numerator is double this numerator?
Yes.
And this denominator is double this denominator, and 12 is double the 6 denominator here. So now, when we make equivalent fractions, we can do so by, if 2 is 2 more than 1, 2 times more, and 6 is 2 times more than 3, we can take our original fraction and multiply it by a fraction named for 1 to generate and make an equivalent fraction. Okay, so let's try that. All right, so if 1/3, if 2/6 is twice as much as 1/3, what fraction named for 1 should we multiply 1/3 by? What fraction named for 1? 2/2. Very good. 2/2. Okay, so let's multiply. 1 times 2, and 3 times 2. 6. Okay, do you see? And then when we originally look at your model that you drew, do you see that you could see that 2/6 when you divided it? You generated a fraction of 2/6. Now, notice that 2/6, that 4/12 is twice 2/6, and 12 is twice 2 times more than 6. So what can we multiply 2/6 by to get what fraction named for 1 should we multiply 2/6 by to get 4/12? 2/2. And then we get 6 times 2? 12. 4/12. Now, what if we did, if you did, let's take our original fraction when Joe cut his pan of brownies originally into 1/3 pieces. Do you notice that 4/12 is equivalent to 1/3, and 4, the numerator 4 is 4 times more than 1, and 12 is 4 times more than 3. So what fraction named for 1 can we multiply 1/3 by to get an equivalent fraction of 4/12? Okay. 3/3? Let's try again. 4/4. Very good. There we go. 4/4. Okay? And then we multiply straight across. 1 times 4 and 3 times 4. So you can see how those fractions are equivalent. Now we're going to compare a couple fractions using our fraction strips to see if they are equivalent. And then if we'll see if they are equivalent, and if not, we're going to discover, I want you to tell me why you think they're not equivalent. So we're going to compare 2/4 and 3/8. So with your fraction strips, you're going to take out your 4ths and your 8ths. Okay, so go ahead and take those out. Okay, so your 4ths Okay, so if you haven't, here, go ahead and use these because these are cut apart. Okay, so take out your 4ths and your 8ths. Yes, they have to be all cut apart so that you'll be able to manipulate them. Okay, so get out your 4ths and your 8ths. And you're comparing 2 4ths and 3 8ths. And let's see if they're equivalent. Okay, so just lay them out. 2 4ths and 3 8ths. Okay, here we have the 4ths. Do you have the 8ths? There's the 8ths. Okay, do you have your 2 4ths and then 3 8ths? Lay those right out underneath. Okay, and then compare those. 2 4ths. Okay, you're okay, honey, because you only need 3 8ths. Okay, so just 2 4ths. You're comparing 2 4ths with 3 8ths. Okay, so line them up right underneath each other so you can compare. Here, let's trim this up a little bit so that you can. There you go. So you have 2 4ths, so line them all. Okay, so as you're comparing 2 4ths and 3 8ths, are they equivalent? Okay, let's look at that. 2 4ths and 3 8ths. Okay, you're saying they're not equivalent. 2 4ths, and we're comparing, so we're going to use greater than, less than, or equal to. But right now we're just going to do whether they're equal or not equal. Okay. So you're saying that, and you can see using your fraction strips that 2 4ths is not equivalent to 3 8ths. Okay, so we're going to use the unequal sign here. Now, if you were to apply multiplying a fraction name for 1, that you would get a denominator of 8. Right, so if you were to, let's say that you, one of your options is to use your fraction strips, but let's say, let me try it using a fraction name for 1. So you know that if you multiply 4 by 2, you would get a denominator of 8, correct? And remember, you have to multiply by a fraction name for 1. So if you multiply straight across, what's 2 times 2? 4. Okay, so 4 8ths. And this is 3 8ths, so you would know, oh, it's not equivalent. Now go ahead and put another 8 underneath your 2 4ths and see if it's equal. Very good. 2 8ths equal a 4th. Yes, very good. So now do you have 4 8ths is equal to 2 4ths? Can you see? So you can use your fraction strips to find equivalent fractions, and you can also use your multiplication by multiplying by a fraction name for 1. Okay? So let's try a couple more to generate some more equivalent fractions. And you can use your fraction strips, or you can we can use the multiplication of the fraction name for 1. Okay? So if you look on page 229, there are models there. Yes, 229. You will see 2 models, and the first model is shaded in. What fraction are they naming in that? Can you tell me the fraction shown in that first model? Okay, what is the fraction? 1/5. Okay, 1/5. So it's showing that the part that we're counting here is shaded in, and that we have 5 parts, and that tells you how many equal size. This is the denominator telling you how many equal size parts there are in the whole. Okay, and now we want to make, we're going to take the same rectangle or the same pan of brownies. Okay, we have this shaded in, and we want to make an equivalent fraction. So what can we do to this model to make a fraction that is equivalent, naming the same parts as 1/5? What can you do to this model? Okay, so you want to divide this pan of brownies all the way in half. Okay, so are we still naming the same part here?
Yes.
We haven't gone out here and named any other parts. We're still naming the same part. Okay, now how many parts of the whole do we have now? You have 10. So 10 is our denominator. And how many parts are we counting? 2. Okay, so 1/5 is equal to 2/10. Okay, so you can see it. You can draw a model also and use your fraction strip. So if drawing a model, seeing this visually, if that helps you, you can draw a model. Let's try it using multiplying by a fraction named for 1. Let's do that method also. So what fraction named for 1 are you going to multiply by to get a denominator of 10? 2 halves. And we'll multiply across 1 times 2, 2/10. Okay, so 2/10 names the same part is equivalent to 1/5. Okay, so it still names the same part, right? Okay, let's try number 2. Would somebody like to lead us through that? You want to lead us through that, Lana? Okay. So start from the very beginning and just tell me what to do with the model. I'm going to draw a pan of brownies and then you tell me what to do. Okay, so my brownies are divided into, okay.
And shade in 2.
Shade in 2. Okay, and what fraction is that? 2/3. All right.
Then you can do split that into 2.
Okay. I'm now going to make thirds. Okay.
And there are now 9 altogether.
9 parts of the whole. Okay.
And 6 shaded.
6 of them are shaded. Now, are we still naming the same parts? We're still naming the same parts. Okay, very good. So, if we were to multiply by a fraction named for 1 to get a denominator of 9, what fraction named for 1 would we use? Lynn, can you help us? 3/3. Very good. And let's multiply across. 2 times 3?
6.
6. 6/9. And let's check. 1, 2, 3, 4, 5, 6. So those are the parts that we're counting. That's our numerator, 6/9. Okay, very good. Could you try, go ahead and try number 5 and 6 on your own and I'll check it. Try 5 and 6 on your own and I'll check it. And then I would like a volunteer to tell me what you chose and why you chose it. And we'll do it mathematically to see. Okay, can somebody walk us through problem number 6? Hey, Evan, you want to take us through that? So we're comparing 5/8, and we're comparing that to 2/4. Okay? It is not equal. Okay, so Evan says it's not equal. Can you walk us through and tell us why it's not equal? Okay, very good. So your numerator and your numerator and your denominator, remember, you have to be able to multiply by a fraction named for 1. So the numerator and denominator have to be the same. So Evan says, if you look, 4 times 2 is 8. But you can't multiply anything by 2 and get 5 because 5 is not a, no, 5
Isn't
Isn't
not
not-
a factor of 2.
is not a,
Factor of 2.
not a, no,
Multiple.
not a multiple of 2, right? So 2 times, there's nothing that you can multiply 2 by to get 5 because 5 is not a multiple of 2. Now 4 is a multiple of, 8 is a multiple of 4, but remember you have to be able to multiply the numerator and denominator both by a fraction named for 1, okay? In order to get, so you can see that it's not equal. And so you work backwards, and I also heard you say the word divide, okay? So remember, the inverse of multiplication is division, so you could have gone this way. 5 divided by, what is 2? Oh, that won't work. But 8 divided by 2 is 4, but since you know that 5 is not a multiple of 2, immediately you would know that they're not equal. Okay? So you could work it either way, either multiplying from this direction or Evan said he divided. Okay? And division is the inverse of multiplication, so you can work it that way. Okay, and the next problem was which one?
Number 5.
Number 5. Let's see, 4 twelfths. And we're comparing 4 twelfths to 1/3. Okay? Would somebody like to walk us through that one? Glenn, you want to try that one? Try that one for us. Okay, 4 is a multiple of 1, yes. And okay, so they are equal. Okay, do you all agree? 4 is a multiple of 1, 12 is a multiple of 3. So if I were to multiply it 1/3 times what fraction named for 1 would I have to use to get 4 twelfths? 4 fourths. Okay, so they are equal. Very good. So you can take your knowledge of your multiplication facts, of the multiples to check, and then you can also do your division if you were starting in this direction, because if you started here, 4 divided by 4 is 1, 12 divided by 4 is 3. Okay, since division is the inverse of multiplication, or you could have worked in this direction. Okay, but Glenn took his knowledge of his multiplication facts, knowing the multiples of these this fraction here. Okay, very good. Okay, any questions? You all did very well. So remember, you can use your fraction strips, you can draw a model, or you can use your multiplication by a fraction named for 1 in order to make equivalent fractions. Okay, very good. So your homework in your workbook, 6.1. Good job.